And now for the grand finale. It's Rubber Duck Engineering number 67, I think. Not the finale of Rubber Duck Engineering, just the finale of our Agent
Battle Royale.
Our Battle Royale. This time with crowns.
So at the end of the last episode, we invited the community to submit pull requests for agents for this Battle Royale game.
And the community did.
Being not so great YouTubers, we did this in like the last few minutes of an hour-long video. But somebody watched to the end.
We have proof. Someone watched to the end. Yes. Hello, Adam.
Hi, Eric. How are you?
I'm well.
Good. I'm well too. Thanks for asking.
Oh my goodness, it's all a blur. So yes, we had a contest and we got a submission, and we're going to review the submission and run it through our system and have some fun.
Sounds great. Should we go to the code review machine?
Well, I think we should do the code review machine.
The code review machine, yeah.
The code review machine, like this one.
Bum bum bum.
Bum bum bum. And by the community, we mean me, Deb.
Michael, thank you so much for submitting. We really appreciate it.
Yes, it was very kind of you. So Michael added Cautious Seeker.
Similar to Opportunist. That's a good start because Opportunist is like the current, like previously was the best.
It was the pinnacle of our
attempts. Instead of running away, it seeks the pieces. Okay. But to avoid becoming eaten, it never gets too close. I see. So it like, that makes sense because the Opportunist, I think, runs away instead of seeking. So it draws against the other sort of pacifists. But if something comes close to it, then it has a better chance of getting it. Like random, for example, would come closer to it. That makes sense. So it seems like a good strategy.
Yeah. And then I have to click this button. We added the Seeker. Here's a subclass. Ooh, we're orange.
Orange for us.
Distance the nearest piece. Oh, wow, with an assert. Don't tell me there's a unit test in here.
I see. Walking distance. Yeah, this is a sort of problem with our design previously, is we were doing distances like diagonally cutting through the board. But I think walking distance probably accounts for the fact that you can only move along the actual grid.
Okay, distance nearest piece, yeah. Fold, and then we take the, yeah, okay. This makes sense.
I wish I knew these like like list combining operators this well. Like I always know there's like a map, fold, reduce, zip thing that does exactly what I want, but I can never, I don't have them at my fingertips to like know what it is.
Well, you really want this thing right here to be a like a shared function, because this is really like smallest, right? It's like map, fold, smallest or something like that. But yeah,
it's like less than, but with null, like a null aware less than or something.
And I don't mean that like this individual should have broken this out, although I might have. It's more that I like, you kind of want that in order to make this pattern really slick. Okay.
Enemy position. Okay, that's a good idea.
Pick, move, other kings.
They're also way better at using final than we are. Like we use var all the time, and we should be using final.
Too much rust.
It's not safe. Okay. Delta 2.
Oh, I see.
So it filters out among our legal moves the ones that are too close to the enemies that would allow that would get us eaten.
Yep.
If there's nothing safe, then we're in trouble. Then we roll some dice, do as well as we can do.
Okay, find the move that brings us closest to the opponent. Oh, interesting, because we want to like hover right outside.
Right outside like stomp radius. And we want to hope that they walk into stomp radius. Okay. And then we're doing best move. Cool.
Walking distance is max of...
I see, because you can move diagonally. So it's like the shortest of the sides.
Okay.
Makes sense.
You mean the longest of the sides?
The longest of the sides. Yes, sorry.
Yeah. All right. This is get positions if. Oh, I have a predicate here. Piece owner. Predicate piece.
Huh?
All right.
General
This is reuse. Yeah. Its positions. Okay.
Okay.
Get positions if we're the owner and it's the type that we think. If we're not the owner, it's the type we think. Makes sense.
We're sort of mixing the like get not get kind of style or whatever, but that's fine.
And you were thinking that this may be the like Linux template.
Yeah, I think this person was working on Linux, and so they added Linux support to the project. I don't think they typed all this. I think this came out of the template.
Flutter Create, yeah.
Flutter Create.
I guess I've never used Flutter from Linux because I haven't had a
Makes
Linux
sense.
machine in a while.
It runs everywhere, so.
I didn't even pay him to say that. I promise.
Someday I'll have a toaster that runs Flutter, and then my life will be complete.
Oh man, I'm sure that exists. Or if it doesn't, someone should tweet it at us. Okay. Yeah. This I know is generated. This is like the register the plugins.
This looks great. I don't think we could have asked for a more beautiful submission.
Yeah, this is great. We should merge it and we should try it.
I'm on board. Let's do it.
Okay. I have to press a button called merge somewhere. Oh, I have to sign in.
To sign in.
Are you able to press the merge button?
Yeah. I'm signed in. I can press the merge button.
Not publicly on the internet?
Wrong project here. Pull requests. Project seeker. Merge pull request. Boom, it's been merged.
Oh. Ooh, 3 commits. Wow. Look at that. The merge commit and the 2 commits from Michael. Okay. Let's open her up. Let's give it a run. I'm always hesitant because I started my coding career back when debuggers were super heavyweight. To use the like start with debugger
to attach with the debugger,
but I know
that
that's
run with the debugger.
Modern way.
Why not? I would just run with the debugger. Like, why not?
Well, but back in the day, it used to be way slower to run with the debugger when it was GDB and all that.
I was trying to so I'm so used to systems that attach the debugger on crash. I was trying to explain this to the future team. I was like, okay, how about when a program crashes, we attach the debugger? And they're like, why don't you just run with the debugger all the time? And I was like, I'm old. That's why I forgot.
Okay. Oh, look at that cautious seeker.
Cautious seeker. Oh wow.
Strong start. We didn't write down how many runs we've had.
No, we didn't. We could add that while it's running. But
okay, let's do it. That sounded like a challenge. Made.
It's like the least difficult challenge. To me, this is like the definition of hot reload. It's like, okay, the contest is going on. We don't want to affect the score. We want a readout of more information in the leaderboard, please.
Let's see. Where did we start? There's the like on pressed, right?
No, just the game state has a count, I think.
Of the number of games that have run?
There's like a game history in here somewhere.
Okay, game history. Oh, I see.
You just want to display it.
Yeah. I didn't realize we were eventually going to run out of memory.
It's just an integer. It just like.
No, but don't we keep a map of all the game? Oh no, but not of all the game states.
I don't know why we keep the game count.
As percent. We listed here as part of the percent.
I see. Oh, for the divisor. That makes sense.
But
You
we
just
just
add it to the percent. Just put a parentheses, the like n equals something.
well, but then it put it on every single. We just put it like at the top or the bottom.
Oh, why don't you put it as in the header for the percent column? Percent, yeah.
Oh, okay.
Because it's relevant for interpreting the percents.
Sure.
Just n equals $ game, whatever.
You're assuming that I remember how to do this at all. Oh my God. How do we
It's
interpolate in?
n equals $.
There we go. Yes, game history dot. Yes, that looks reasonable.
Add. So there's something wrong.
It's
That's
not
not a constant anywhere.
Nope.
Table cell is not a constant anywhere.
Yeah.
I wish the constant thing would just be like inferred.
Well, and it got worse in the with the most recent lints, where like the lints really nag you whether you const or not.
No,
cannot be.
There we go.
The evaluation of this constant expression throws an exception.
Well, the whole
Since
row
what is
is
a constant expression?
Boom. Nailed it.
Evaluation of null is game count null.
I mean, maybe it could be. Game history can't be null. Game count can't be null. No.
Evaluation type.
The value type null.
Constant value. I don't understand why we think we're const here. Oh, is it because our padding?
Oh.
It was our padding.
Oh. Okay.
Great. There we go.
All right. Cautious Seeker. I don't know. Should we go to 1,000 before we declare crown a victor? But it's looking pretty good for Cautious Seeker.
I think with this many polls in, the decision desk here.
You're willing to project that Cautious Seeker is the greatest agent ever to walk the Lambda battle?
Yes.
All right. Yay! Cautious Seeker! Michael, congratulations. You are the victor.
Good job.
That's really remarkable to me how much better it is than Opportunist.
Well, it actually tries to win.
It's like part of the pacifist club. Like if it's in a game with a bunch of pacifists, it will play pacifist. But if you ever like, it's right on the edge. It like walks up close to everybody.
Yeah, I mean, I think that one could do an even smarter. Yeah, that just took a little bit more risk. Like when the EV was worth it. But
you like study your opponent. Like you look like you're just moving away from me. I'm gonna get close to you.
Is it sometimes fighting itself? Is that?
Well, if you just have two Cautious Seekers, they'll come together. We can try to make a demo board of this. They're there. See, they'll get right next to each other, but then they'll just dance.
Yeah.
They won't actually come close.
Which makes sense. Like that is the best outcome. Because anyone who gets closer is going to. What'd you say?
Yeah, anytime you get close, you run the risk of the opponent coming and getting you, right?
Mm-hmm.
Like in regular chess, you're not even allowed to make those moves.
Yeah, exactly. So I think we should now try and change how we're allowed to move and see if how the agents deal.
I think that's a really cool idea. But maybe before we do that, what if we just made it have 64 contestants and left?
Whoa! Like the blob.
Like the blob. There may be a problem with our random selection of placing things.
With random agents. Oh, I see. Because it probably didn't.
Like it starts to become important. Like, did you? Oh no, it'll find empty spots. Try it.
It'll take a while.
Look, this is a supercomputer. Like nothing takes in.
It's like we're playing Candy Crush or something.
Yeah, but then they start going crazy.
Okay, but I want to reset the scores.
You have to do a hot restart. Sorry. Do you think it's going to change? Like what the best algorithm is in like
I wouldn't.
Super Royale mode?
Well, actually, I think what this should. I enjoyed that they were chasing each other at the end.
Yeah, we're totally going to do more peace types. That's a really good idea. Or just change this peace type to be like a queen instead of a king or something.
Is it gonna? I mean, the dominant algorithm, right? Cautious seeker. The best algorithm when there's two of them is for them to draw.
This seems to be like Cautious Seeker seems to get to the end in almost all of these boards, right?
They should. This should be putting more pressure on the like avoiders, the runners,
because they can't run away. They'll probably get stomped before they run away.
Well, just there's always there. Previously, the like I just want to draw benefited from the like ecosystem. This is totally, we're going back to our ecosystem simulations. The ecosystem being full of things that also wanted to draw, right? It was like the doves and the wolves, or the doves and the hawks, right? It was super common that you just ended up with doves. Now with 64, you're much more likely to have at least one wolf, although Cautious Seeker isn't as wolfy as we could make one. Does that make sense?
Yeah, but look at like random mover, like Fixate is just horrific at this format. Like they just barely they barely won a game just then. Interesting that the elos are less spread out. Because I guess there's you'll lose a lot. Like even if you're really good, just in the first couple of moves you end up losing a lot. And so the percentages reward survivors. So the people who die out don't really get penalized.
Well, we're also stressing our like multi-elo thing, because doesn't it like calculate the spread based on?
Well, like just say, let's say you're a Cautious Seeker, right? And you just happen to be next to a random who like stomps on you the first turn.
Correct.
You'll get a like lost to random.
Well,
look how flat the elos are. They're super flat.
It's also that the elos are not for like, there aren't two Cautious Seekers with two separate elos.
Right.
I guess it doesn't matter. I was just like the Cautious Seekers. Yeah, you'll end up getting stomped.
I bet if we change it so that the elo is like evaluated by type instead of by piece. So we'll take like the best finish of your type of agent in this arena, as opposed to all instances of your agents.
Oh, so biases towards winning in that way.
Well, it just imagining that all of the like seekers are all controlled by one player essentially, as opposed to thinking them all individually.
Okay,
because that's kind of what we're saying here. Like we didn't list like 17 seekers, right? We said we accumulated them all.
All right, so if we were to do that,
yeah, just this is like a general technique, which is if you make really extreme inputs to your system, you can learn a lot about the dynamics of your system. So like we learned that the ELO is very sensitive to this issue by filling up the board with things, right?
All right, so record game. So we want to like somehow simplify the dead players list.
I think we want to work on types of players instead of the players themselves somehow. So we want to order.
We want like an absolute ordering of all the player types, and then a marker with whether they died or. Like if I gave you the data structure that was like type did die.
Yeah. but you want like an order.
But yeah, you put this in a list, right?
Yeah, so I'm sure there's like a. Okay, so maybe we just need that.
And I wouldn't do it in arrays, right? Like, so we had a struct. I don't need a prescribing solution, but I think that if you had this data structure,
right. So I think if you had a map from type bool, that was like have seen. Okay. And you have the like dead types, which is a list of type. And you have alive, which is a list of type.
So you could also just
this can just be a list of there.
Can't you just basically do a map over the?
Yeah, I think this is going to work just like what you're saying. So we'll take the normal alive players. Let's pull them up here. Okay.
May I describe to you an alternate that I could imagine?
Please.
So you could take the the dead players and walk them in death order, matching them to their type. So then you have a list with possible duplicates, and you walk that in reverse order, removing ones that you've already seen.
I think that will work, but I think you can do it in forward order like this.
Okay.
Let me get the right. Basically, if you walk the players in order, and you say,
okay,
the result is have seen player dot runtime type or false, and you say,
why is it a filter?
because I want to only select the first ones. So as I walk through the list, once I've seen them, then I'm going to start returning false, and they're going to be filtered out of my list.
Okay.
And then dead player is the same thing. You can say you want to apply the same filter. This is like a have check player. I want to make a function just like this, I guess. So I want to apply the same filter to both the alive players and the dead players.
Okay, yeah. Which order are we walking the dead players? From most recently dead? Because you want to bias towards, you want to
your best showing, right?
Yep.
So then I think we can just change all of this to refer to our.
Okay, yeah. Yeah, that's great. You almost want to rip this out into a different function so that you you don't even pass in the game history.
Yeah, that's a really good idea. So why don't we do that? So all of this, right? This is like.
List player or something?
It's really important to make these iterators turn into lists because it's the predicate is stateful, so you want to make sure you're executing it when you think you are, as opposed to like lazily as you draw through them. Okay.
Well, that's just another advantage of doing this in a separate function. It just it makes clear
exactly what's going on. Yeah.
It's scoping out this game state so it doesn't actually get passed.
It's got squiggles. So the squiggles mad at you?
Return type can't be var.
Oh, how about void?
The rating is already defined.
Update all ratings.
Sure.
Oh, record ratings.
Ratings, you said? Filter is not defined for type list.
Oh.
It's like where, I think you mean.
Oh, I see. Where? Okay.
Site abuse. Okay. Function declaration define a name.
Oh, I think you can just say.
Yeah, you can just.
Cool.
Yep.
Exactly. Not
okay. What have we done?
I think we should do a hot restart though to reset all the elos.
We were remarking before the show tonight that this really was not our best example of rubber duck engineering because we didn't even write a single test case.
Yeah, like we have no idea if our elo calculation does anything at all reasonable.
Well, we know that it selects cautious seeker as the winner, and that's important.
We did talk before the show how if that didn't happen, we would hack the rating system so that cautious seeker would win. But that wasn't necessary.
No, so they won on their own 2 feet. Winner is seeker.
We messed up somehow.
We had this exact bug before, didn't we? I feel like we had this bug before.
Can you look at the diff? Like, what did we change?
Chord rating. And main const.
That seems fine. Like that we didn't have trouble when you have to delete a word.
I swear we had this problem before.
Yeah, we did, where we somehow weren't ending the game. But oh, maybe we're throwing an exception. That's what's going on. We're supposed to look at. Yeah. That's right. Maybe we should put a try catch blocker on this since we had this problem before.
There's a little button there. Output. Debug console. There we go. Yeah. It strikes me as strange behavior that this is what bad state, no element. That this is our behavior.
Oh, there may not be any alive players.
That I think was basically exactly the bug before.
How can that be true though? The alive players maybe our predicate is messed up. Oh, we need to default to true. Yeah.
Result have seen true.
No, we just need to return the not of this.
Well, okay, yeah. That looks reasonable. Oh, we've started having games now.
Yeah. Do you want to hot restart it so we get a clean state? All right.
So what are we expecting this to do?
I'm just expecting a larger ELO distribution. Like before, the ELOs all ended up within like 1 or 2 points away from 500.
Yeah, because this is filtering out the randomness where you cautious seeker or whatever just got stomped.
Yeah, like in all these games where cautious seeker, like here, is it visible at the end, they get the win. Whereas before they were getting 30 losses and 1 win.
Yeah. There is still a randomness where if you didn't, yeah, but those should filter them out.
You could all get stomped out during the beginning. That's true, right. But you won't accumulate like 20 losses every game just because. Which is clearly happening, right? Like the ELOs now have a much wider distribution, and actually matches more like the percentages, and also more like what it did in that smaller setting.
And this is matching what I would expect, at least. Like first mover, which just picks the first move, was terrible, and so is the absolute bottom. Yeah,
somehow even worse than random mover. Although they're both pretty bad. And runner has some chance. If they randomly survive to the end, they can draw and get some points.
First mover is very easy to seek after, whereas random mover might be harder.
Seeker is not on this list at all, by the way. I think in this metagame, Seeker is very bad. Because Seeker and Opportunist will head towards each other, and then Opportunist will Seeker and Cautious Seeker will head towards each other, and then Cautious Seeker will just wait the one move, and then Seeker will come into range and get stopped.
Does Cautious Seeker actually wait? Is waiting a valid move?
No, it can't wait. It'll just dodge, right? It won't. Oh, yeah. In the move, like if there were two Seekers and it was the one that was going to come into range first, it'll just move to the side, and then Seeker will come closer to it, and then it'll come and get it.
It's interesting that Cautious Seeker is basically in this the anti-Seeker. What color is
it really preys on Seeker.
Yeah.
And random mover to a lesser extent, because random mover, whatever, a third of the time will move into range.
Mm-hmm.
It really demonstrates the importance of the metagame, right? Because before we had Opportunist or Cautious Seeker, Seeker was on top of the metagame.
Mm-hmm.
And now Seeker is not even has 0 points. Like it's lost every single time.
That's amazing. Yeah, I'm surprised that Seeker hasn't ever won anything. Is it? I guess because Opportunist also preys on.
Right.
Whereas First Mover has won once. I guess that's the one random that Seeker will eventually hit. Shall we try some crazy move types?
Sure.
What do we have for? Single move. Single moves. Single moves. Can move piece 2.
It's piece deltas, I think, is what's going to control it.
I don't. This is the code you wrote.
This is what I wrote off air. But if you go to the piece deltas, you click through deltas there.
Huh. Okay. I think if we changed king, that might break Opportunist.
Yeah, I think we've hard coded king in a bunch of places. So
yeah. So I think king is just going to have to learn here.
What do we change it to -8 to 8 instead of 1 to 1? Just turn into a queen. Yeah.
That's going to allow us to be out of bounds, or is that going to?
That's fine.
No.
Not a problem. It's something else we'll check whether it's actually in bounds and such. You can't write code with that part of a switch statement, but aside from that, it's great.
Yeah. Details.
Is it mad because it's a...
Prefer const.
Okay.
Okay.
I think we just turn down... Yeah, can we go down to like 2... No, not range 2. I mean 2 different players.
Oh, well, this would be better if we showed them moving.
That will take more than the remaining time to animate the move.
Why is that?
Oh, I mean, go for it. I thought about doing it as an off-screen hacking project. Maybe I was trying to do it too fancily. I was gonna make a lerp where you could lerp the board states and have the positions be like fractional. I think let's go back to 8. But let's turn down the number of players. Like turn down the number of players, put the number of players back to 5 or something reasonable, and then we can also turn down the game speed so we can see a little bit more what's going on.
I mean, this is effectively teleporting. Oh, especially since this is not 8 in a direction. Right. We gave them
well,
teleportation.
They can literally go to any square. That's true.
Correct.
So random is just going to boop, 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 and Seeker is just fuck.
And Cautious Seeker is going to not know what the F to do.
Okay, maybe we should make it actually queen moves instead of literally like the ultimate piece that can go anywhere.
Okay.
How do you? Oh, that's interesting. I think you put the range inside. Like you permute the loops, or you add another loop, basically. Like if you go back to -1 to 1, right? And then you say for int d equals 1, while d is less than or equal to range.
Yeah. Yep.
You want to be really fancy?
Sure.
I'm going to abuse everyone who knows calculus.
D to the X, oh my goodness. There was like a song we learned in high school. D to the X, dy dx, dx. It's in there somewhere.
Yeah. dx is d times x.
Yes.
Okay, those are actual queen moves.
Okay. Okay. I want to see like one of these move slowly.
There's some milliseconds. We can turn down the milliseconds.
I would also pull these constants out so I have so I know where they are.
Oh, that's a really good idea.
Just so I have any prayer of ever changing them again. Move range. Okay, move range. Okay. And then there was like it's like a millisecond somewhere.
Yeah, that's over in game. I mean, yeah. Main, you're right.
Yeah. That's or something.
There's
Aha, duration.
5 or whatever.
Did you give it a name?
Just move the whole duration there, like game.
Oh yeah.
Duration.
Yep. Okay, we have some prayer of ever finding these now.
Now you understand why in Unity they pull it out under the property pane. Like
what? Oh yes.
Okay, those look like queen moves.
Well, they can also move through other pieces.
That's true.
I think what we're learning is that chess movement rules are.
We didn't really program a whole chess engine,
but yeah, okay. These are actually starting to look more like moves. We would actually make them. We would make them better, I think, somehow. And the other difficulty is that Cautious Seeker can't. Cautious Seeker doesn't know how to actually look to see whether it can see.
to like move off axis. Yeah, of course. We totally broke all the agents. That's fine. I set the milliseconds to it. Can I restart your thing? Oh, I can.
What did you do?
I hot restarted your board from my Visual Studio.
Today I learned.
I just turned up the speed so we can see like who's good in this.
So what would we expect? Why has Seeker come back from the dead? Because Seeker can now...
Because the people who are running strategies against Seeker, their strategies don't make sense anymore. Like there's no point in staying one square away from somebody if they can move like a queen.
Okay.
So like, yeah, it's somehow the strategies that people have programmed are they like assume things about the rules of the game. Makes sense. But like there's another way of doing game AIs where you could like we could have looked at the opponent's possible moves. Like we could have written Cautious Seeker in a way that it tries to get a final position where the opponent doesn't have a move that will.
Yeah, totally.
This is why I'm always very skeptical about like AIs writing code, is because it involves a lot of counterfactual situations. Like, what if the world were different in a way that we'd never seen before? Like, what if everyone suddenly learned how to move like a queen? Like, and so like all the empirical data you've seen so far is not really predictive of the cases or inputs you might see in the future.
There's a danger in over-designing your systems like this, but I also agree with you that I think it's useful to throw stuff at your system and see.
But even so, I mean, Cautious Seeker is the number 2 or number 1 player still, even when we've totally broken the rules of the game according to it. It's just much more similar to Opportunist. Like its cleverness over Opportunist is not really manifesting because that cleverness doesn't make sense with these changed rules.
What's the teal one? Is that random or something? Why do they end up?
How about
I see. They're just moving back and forth.
Teal is first mover.
Blue and red. Oh, you know what we should do? This would be very straightforward.
Oh.
I don't know that all of them have the like color thing next to them, but
they all have a color there. Yeah.
Player. Just looking for it. Oh, can we look them up by value? It'll create a new one, won't it?
I think, what did we do here?
It's right here. This is the text. So we need this to just be styled.
You haven't set it, but what you're going to do is you're going to color code the leaderboard, right?
Yeah, sorry. I'm dependent on the fact that you and I have worked together for a decade, and you have the ability to read my mind, even if I don't have the ability to put words into the air.
We've lost the players at this point. We'll have to change the data structures. But we can change data structures. That's not a problem.
We can get a player out of the engine, right? You can be like, hand me one.
We can also just cache the color.
What did I do? Did I screw this up somehow?
In the game history, I'm just going to record a color for the string. Like I'm going to have a map from string to color.
Sure. A little hacky, but why not?
It's sort of hacky, but.
And then I have to remember how to make this thing have a color. I think this is like styled text or something. Or span. Let's see. Oh.
We've got a color then.
You did it?
Yeah.
Oh, I see. Yeah, no, but we want this style, text, style, color. You say it's in the history?
Yeah, it'll be history dot colors, and then you can pass in the key, e.key. Something like that.
Probably doesn't like me. Positional arguments would be named arguments. What's going on? I must have missed a.
You need another close parenthesis there. And more commas to make it a cool comma formatting style. Yeah.
There you go.
There you go.
Okay. So much better. Oh, except we slowed it down again. Oh, because that was the undo. I accidentally did an undo.
Oh, okay.
What was it, 20 before, something like that?
Or 1, like. There you go. Yeah, the color coding's great.
All right, so that was like. So that's runner and seeker going in some like pattern there. Why are they going back and forth the same move? I see, because runner's trying to run as far away as possible from the given current moves.
Right, they switch sides of the board. They go like this. I'm trying to get as far away from you.
And then the other one's trying to get close to them. Okay, so runner and seeker go into this pattern. Okay,
I see, because now seeker can never catch runner. Because as soon as seeker gets close, runner runs away.
Yes. Well, they can if.
I guess runner got a lot better.
If runner
seeker could like chase down runner to the edge of the board, and then.
Well, or if they just knew how to get onto the like right line.
Right, they're not.
Like if they're
aligned, it ends really quickly and you don't see it. But if they're misaligned,
runner, that was cautious, seeker, and opportunist. Does opportunist have a runner behavior in it? See, there it was again.
Opportunist is a runner unless it's next to something.
I see. Okay, and that was runner and cautious seeker. Okay, I'm interested in the degenerate patterns when they occur.
The draws, yeah.
I have no idea what this looks like. Oh, it looks like it shows up through YouTube pretty well. Okay.
Fixate is really bad at this move. Like it's.
Which is a sitting duck.
It's a sitting duck, yeah.
It's a slow version of this, right? It has no ability to like run away quickly. Or rather, it doesn't take advantage of any advantage conferred by being able to teleport, because it just always moves one in that direction. Right? You see it bouncing across the bottom there.
It doesn't know that it's a queen. It thinks it's still a king.
I do wonder how this would change if they couldn't overshoot each other. I'm not sure how much that would matter.
I don't think it would matter much to these end games because the end games are pretty empty. But maybe in the earlier stages, it would have more an effect.
I also wonder if an agent should be aware of how many moves until draw. Maybe I said this earlier in the episode. I tried a min-max search algorithm, but the game state tree was so exponentially huge, the opponents have a bunch of intermediate trout moves before a player gets the next move. So I gave up lol. Well, I think that's awesome that you tried.
Yeah, that's really cool. Yeah, I don't know. Let's do some very aggressive pruning in all these min-max, because it's in general game trees go exponential real quick, right?
We did design it with the whole like the stateful or the what do they call them? The immutable game state.
That's true. You could do a search, but I'm not surprised that the game state blew up so huge.
Anyways, I think this was fun. I think this was a fun little project. Maybe we'll come back to it. We'll see. I didn't announce at the top of the show. We will be at not the same bat channel, not the same bat time next week.
Well, same bat channel, different time.
That's true. We decided we were too famous for Thursdays. And so we're trying a Tuesday, but only next week. Yeah, it's a limited engagement.
Tuesday next week, and then we'll go back to the regular Thursday schedule after that.
Yeah. So we'll announce it on Twitter too. But So next week, when you go to watch us on Thursday, you can watch the pre-recorded on Tuesday, like we're the Colbert Show or something like that.
And then we're gonna do a new project. Is that right?
And I think well that, or maybe we'll do we'll do
Did
something.
you really? That's so cool.
What does that even
Can you send us a
mean?
screenshot or something? Like I'm super impressed about that. You're mesmerized, Eric. You do know that Flutter runs on Fuchsia, right?
I do know that Flutter. I mean, I'm intimately familiar with Flutter running on Fuchsia, and sometimes taking up too much memory. I'm just trying to like imagine what that means in practicality, because I presume it's not on like a device that I'm normally used to Flutter running on Fuchsia running on.
Oh, you can build this workstation product in open source, and then it runs on like emulators and some hardware. I don't know if Morse code has hardware, but it also runs quite nicely on emulators.
Okay.
It looks like Morse code is on Linux, and the emulator works pretty well on Linux. The emulator is a little slow on Mac.
Okay. I think we did it.
We did it, team.
Go.
I really appreciate the contribution and the like thinking through and trying different things. I think that's really really great.
It's so cool. It's so cool to realize there are other humans out there. Like part of why this got started was that Adam and I used to hang out most weeks, drink whiskey and whatever. And then you just couldn't do that when there was a raging global pandemic. And so instead we've been hanging out on YouTube, and it's fun that, when others come and hang out with us too.
Yeah, I had to get this whole like audio video like light set up anyway. Might as well use it to broadcast.
Yeah. Oh, it was the best. I can't imagine. I totally understand why I didn't do it, but I wish at some level that I had done this sort of audio video setup 10 years ago. I know we didn't have, Zoom and Meet and stuff, all that, but it's just so nice to have it around.
Yeah, it's one of these big changes in the world to like give you the kick in the pants it needs to like go out and try something new. I've had a lot of fun doing the show, and I hope you all have had fun joining us and coming on these adventures, and we'll hopefully continue doing them for quite a while. And
just because we're 67 episodes in does not mean we're done.
Well, to me, it means we really got to get to 100. Like, I'll be disappointed if we don't get to 100 episodes.
I mean, we may still be working from home by the time it's 100. Let me start VM in a minute. Oh. So before we go, anything you learned exciting this week you want to share?
I'm learning all about how Unix domain sockets work.
I'm sorry.
They're fascinating. They almost make sense, but they're a little confused. Like it's very like the part that's the strangest is so you can have a stream-oriented socket. So that normally you write a bunch of bytes, the receiver reads a bunch of bytes. The receiver doesn't care how you've like in what chunks you wrote it, right? But you can also attach ancillary data to your message.
Mm-hmm.
And the ancillary data forms like boundaries. So if you do a read, no matter how much you ask to read, you'll never read past the point where they inserted the ancillary data. So you'll read the bytes up to that point, and then you get the ancillary data. And so it becomes this sort of a hybrid stream datagram transport, which I cannot imagine the designers intended as part of their design. I think it just sort of fell out of the implementation. Anyway, so I've been learning how all that works.
Sockets was like one of the very first real bits of programming that I learned. Maybe not real, but I remember I was in college, and I interlibrary loaned the. It was like the purple book, the like Linux system admin book or something. This was in the 90s. And then the like volume 1 of like TCP/IP networking. And it was like, I just literally read this like TCP/IP networking textbook that I interlibrary loaned from Berkeley, California, to my little dorm room in Wisconsin. I learned about BSD sockets.
Yeah, so it's very interesting. So there's named pipes, which were clearly designed with the original system and like totally makes sense in the system.
Okay.
And there's like BSD socket API, which
Mhm.
makes sense for talking on the internet.
Sure.
And then Unix domain sockets are like this mashup of the two. And like it almost makes sense, but not quite. Like normally on the internet, when you bind a socket, you give it like an IP address
Mhm.
and then you communicate with it. But a
You
Unix
give it a
domain
socket
socket,
or whatever, but yeah.
yeah, you bind it to a path in your file system and it shows up as a node in your file system, like sort of as if it was a named pipe, but it has a
Mhm.
different type. But then because the BSD socket universe has a concept of address internally,
Mhm.
if you then rename the node, you get this strange disconnect where your socket's address doesn't really map to where your node is, or like in a file system, your node can be hard linked from many different
Mhm.
places. And then the other weird thing is, like normally if you have a named pipe, you can open it and you
Mhm.
get out a pipe, right? But if you bind a socket into your file system, you can't open it. The open operation fails with an error that says, "Sorry, you can't open a socket. Don't be crazy." Instead, you have to connect to it. It's
Huh.
just it's like it's like this mashup of these two worlds that almost fit, but then don't. But
What
somehow
is
the
it
universe runs
used
on it.
for? Why do you want to
Unix
use
domain sockets are used for like everything. Like dbus like runs on Unix domain sockets and like
it? Why? It's just like a local socket API, basically?
yeah, it's like the best of the Linux IPC mechanisms. So like there's all kinds of stuff in Linux. There's named pipes and there's system V, semaphores, and all this stuff. And the in sort of stock Linux, Unix domain sockets are the best. So like when Chrome communicates between its browser process and its render process, that
Uh-huh.
bottoms out in a Unix domain socket.
And that's just because it's fast or reliable, or like what makes it the best?
There are two things that make it the best. So thing one is it's relatively clean, like it'll transport bytes for you.
Mhm.
And then the other part that's really important is it allows you to send file descriptors. So that the ancillary data that I mentioned,
Yeah.
the main thing people use it for today is you can attach file descriptors and then travel with your message.
Yeah.
And that turns out to be incredibly useful.
Yeah. You need to be able to pass handles.
All right, so Morse code has sent us an image URL. Do you want me to pull it up here and see what it is?
I tried to click. I mean, I can click on it to show it to the viewers.
No, but like I think I can screen share it if I type into my browser here.
Oh, I see.
I'm
Yes.
imagining it's going to be Fuchsia running Mind Battle.
I hope so, because I just showed it to unsuspecting.
I'm going to assume those are O's and not zeros.
Those look like O's to me.
Oh, yeah, this looks legit. Okay. Let me put on the screen share here. Share screen. Window. That window looks right.
Oh my goodness.
That is amazing. Amazing. I'm super impressed.
Why is it not resizing? Is that an overlay? I'm not familiar with the workstation product. Is that the thing on the right?
This bar on the left is an overlay. And so if you mouse out of it, it'll collapse.
Mm-hmm. And what about the bar on the right?
The bar on the right is also an overlay.
I see. So it's just there's two overlays that are obscuring the.
Yeah, they did this way to demonstrate that when the overlays are gone, that the application gets promoted to a direct display controller layer and runs faster. They were just like flexing their like awesome compositor muscles, but then they ended up with a sort of wonky like system to show.
Yeah, that's very cool. Thank you for sharing Morse code. So, okay. Well, I didn't talk about what I learned, but mostly what I learned was management-y stuff this week. We're still doing our yearly performance reviews and all that stuff. So I did lots of management-y stuff and planning-y stuff.
Well,
not a lot of coding.
Fun of a different sort.
Yeah, it's fun of a different sort. But anyways, We've done our hour, so we shouldn't keep the people's waiting. But
See you next
this
week
was
on
fantastic.
Tuesday.
Tuesday, yes, Tuesday, 7:30. See you then.
See ya.